Miss Collier explains.
Solving by inspection!
Today, our learning intention is to understand that the solution to an equation is the pronumeral that makes the equation true, and to be able to use inspection to solve equations. We will know we are successful when we can solve equations using inspection. Today, we're going to learn about solving equations. And solving equations is about finding the values for the pronumerals inside the equation that make that equation true. These values are called the solution to the equation. Don't forget that the pronumerals are also called unknowns, and they are unknown, but during this process we will try and discover what their value is. For simple equations, we can usually solve it by just looking at the equation and using some common sense and basic math to figure out what the value should be. Or else, we can also use some trial and error to calculate what solutions may work. This method does not guarantee that we will find every solution that is possible, because sometimes it is possible to have more than one solution. This is another situation where we're using algebra in everyday life. Painters trying to calculate the area of space they need to paint, and then usually using different formulas in order to calculate how much paint they will need. Today, there's not much more I need to tell you, except dive in and show you some questions. So first off, we're going to start with finding the missing number. Now this is much like when you were young and you had to do a question and it said like 3 plus what equals 5? And you had this question mark that you had to figure out what it is. This is exactly the same. So our first thing says, for each of these equations, find the missing number that would make it true. And we've got a box there, and we've got to figure out what number should be there. And we've got blank times 7 equals 35. So I have to think, what number times 7 will equal 35? I know that's 5, so I'm going to write it out. 5 times 7 equals 35. Next, 20 take what equals 14? And I have 20 take, well, I know that 20 take 6 equals 14. These ones, you're just kind of looking at them, trying to figure out what number would work in there. They shouldn't be too hard, so you have a go. Let's quickly go through these answers. A number divided by 3 equals 7. That is going to be 21 divided by 3 equals 7. 12 plus a number equals 27. That's going to be 12 plus 15 equals 27. All right, now we're just going to do these examples, but using them as equations. These might get a little bit harder, and I'll show you the second method we can use. So first of all, we have this equation, c plus 12 equals 30. So I've got to figure out what number plus 12 equals 30. Well, if I add a 10, that would be 22, close. So I need 8 more, so that'd be 18. So this is how I'm going to write it out. I'm going to write 18 plus 12 equals 30. But I have to solve the equation, and to solve an equation is what is the value of the pronumeral. So I have to write c equals 18. I have to say what the value of my pronumeral would be. Let's go b. 5b equals 20. 5b means 5 times b. So I have to think 5 times what number equals 20, and that would be 4. 5 times 4 equals 20. And again, I need to say what the value of b would be. b equals 4. This last one is a bit harder. 2x plus 13 equals 21. I might not just be able to look at it and figure it out. So this time we're going to use trial and error. So that means I'm going to take a bit of a guess. Now, I always have to be logical about this. I can't say, oh, x is 50. That's a bit too big. So I'm going to try x equals 10. Now this is how I'm going to write it. I'm going to write out my equation. And then I'm going to write try x equals 10. And then I'm going to replace x with 10, just like normal. 2 times 10 plus 13 equals 21. And then I'll solve. 20 plus 13 equals 21. And then I've got 33 Now, when I get to this step, and I realize they don't equal each other, the last step, I'm going to put an equals, and I'm going to put a slash through them, which means does not equal. And I can see that I have not found the answer. But this next step is really important because it guides me on my next trial. 33. 33 is too big. So I need to try a smaller number. So here I'm going to write try x equals 3. Now, what I must not do is I must not rub this out. I must not think, oh, it's wrong, let me rub it out. No, we have to keep it there. It shows our teacher what we were doing, and it shows our teacher that it was the wrong answer, and then we evaluated it. It would be even a good idea to say x equals 10 is too big. All right, then that shows your teacher that you tried it, it didn't work, but you evaluated it and you picked your next number. That's what we want. X equals 3, let's try it. 2 times 3 plus 13 equals 21. 6 plus 13 equals 21. 19 does not equal 21. So x equals 3 is too small. But notice this time, I'm not going to now try x equals 8 because 19 was really close to 21. So I'm just going to try, x equals 4. I'm just going to try one bigger. I'm also going to take it up here. So 2 times 4 plus 13 equals 21. 8 plus 13 equals 21. 21 equals 21. And I'm going to write then, I have to write at the end what x equals. And I'm going to use this little symbol. Those 3 dots mean therefore. Therefore, x equals 4. So that's how I can use trial and error to figure out my equations also. You have a try, either looking at it or using trial and error. All right, let's quickly go through these answers. A number, take 5 equals 13. That would be 5 bigger than 13 would be 18. So I've got to write q equals 18. B, 2x times 16. 2 times a number equals 16, that would be 8. 2 times 8 equals 16. So x equals 8. C is harder, so I'm going to use trial and error. You may have done different trial and error, but let's see how I go. Let me try 5. Try x equals 5. 3 times 5 plus 5 equals 35. That's 15 plus 5 equals 35. 20 does not equal 35. Needs to be bigger. I'm going to try x equals 12. 3, oh sorry, these are A's. A. Oops. 3 times 12 plus 5 equals 35. 3 times 12 is 36. Oh, I'm already way too big. But I'm going to keep going till my end. 41 does not equal 35. Let's get a bit smaller. Try a equals 10. 3 times 10 plus 5 equals 35. 30 plus 5, oh yep, I've got it. 35 equals 35, but I need to write at the end, therefore a equals 10. I hope now you can see that if we've got simple equations, we can actually solve them by just looking at them and kind of using logic or trial and error to figure out what the solutions are or what the value of the pronumerals are. Here's a picture of my pups. Every time I hop in my hammock, they always want to jump onto me because that gives them enough leverage to see over the fence at what's happening in the world. Nope. I have to tell what the value of what... No. No. Hey, no.